Okay, right now, sorry for this disconnect. Is internet problem? So we will continue right now, and also the pit bath is it's a function for general health conditions. So pit bath is depend on the whole condition and which type of downhole problems we will get. Like some of the well they got like frac formation or losses zone formation. So it is depend on whole condition in general. The second point, when we are just try to planning for a trajectory, we need to calculate the radius for a build-up or also for a dropping section. And also we will discuss that with a with math calculations inshallah in special session. Target radius, it's a formation for a drainage of the reservoir and also geological criteria and its boundary. The The 4 point is regarding kickoff practice. For kickoff practice, uh, as you know, when we are start deviated from the vertical way, we need a half formation to just start to build or friendly formation to build up or just high compressive strength lithology to start creating in angles. So for a kickoff practice, for when we are doing a planning for a trajectory, we should choose a depth with high compressive strength formation or with a hard formation to start a build-up. And during a planning phase, we need to know the lead angle. The lead angle, it's, it's a function for local experience and rules of thumb. What is the meaning of lead angles? Lead angle, actually, normally the azimuth is walking to the right. They call it walking to the right phenomena. Thus, any well, a drill in consolidated formation, the path will go to the right way. Okay, they call it because we are just turning the drilling string to the right, so it's great the walking effect to the bit. So normally the bit walking to the right, and it will be a big issue because you know normally we need to correct the azimuth. So because that, several directional engineer they create they create an angle in the like in the direction of the left with 5 to 25-degree. They call it is lead angle. Okay, because in case the bit start walking to the right, they already create the lead angles to uh, they will be in the same position or in the same path of the well. Okay. Also, for our planning phase, we need to know the target location, and we need to select the optimum location for a drilling rig. It's, I mean, the accessible location for a drilling rig on the surface. Hole size, it's also its engineering job, and casing and mother program, it's also engineering job. We will discuss all the points one by one. And also we need to know the effect of drilling string with magnetic 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 field, and also adjust the wellbore or on the instrument survey, because as you know we are using measuring while drilling techniques to know the survey or to know the inclination and azimuth, and this type of tools its effect with with its effect with a magnetic field. So we need to just adjust the well bore with survey instruments. And geological information, I mean lithology. Of course, the geologists will care about it because we need to know where is the unconsolidated formation. We need to know which type of formation is friendly to buildup and the compressive strength for each formation. And also if there is any bed dip or fault or any downhole problems, so we should start a study about the geologic, and also we should collect a good geological information. Of course, a good planning, it will lead to decreasing the costs in general, and it's a part or a key for a cost reduction. So for that, several companies care about planning phase, and they wanna to just do like a full study about directional well before just start or resume drilling any directional well, or start uh, drilling a directional well. For, for your information, we have several type of build rate or build up rate. It will give us a radius of build section or for a drop section. For example, for a long radius, it's like between uh, 2,800 to 700 feet. We need the build-up rate 2 to 8 degree each 100 feet. For medium radius, we need to aggregate a build-up rate between 8 to 30, and it's like we will get a radius between 700 to 200 almost. For short radius with a build rate 300, sorry, uh, 30 degree to 60 degree, the radius it will be short between 200 to 100. For ultra short or for a sharp well, it will be the build rate 60 degree each 100 feet to 200, and the radius will be just 95 to 30 feet. But this type of well, short and ultra short is not common around the world. Normally they are using long and medium for type of classification or classification of the well. This is the function, or this is the equation we are using to calculate the radius from the build rate. The radius, it's the function for a build rate, so it's just we divided 57.3 on the build rate, then we will get the radius. Sorry. So inshallah, tomorrow we will continue our presentation with like directional drilling and also directional well. We will start some small calculation regarding directional well or deviated well. Uh, we'll talk more or deeper on the BHA. Also, we'll talk deeper on the torque and drag and downhole problem that will, or we will face it during directional job. So please, any question or anyone need any answer or anything I can help with, just drop me a message on the email or on my Gmail or on my Facebook. Also, I have a LinkedIn on the same email. So you will get an answer. I will try to just try to upload this presentation on the Google Class. So please, any question?
How are you, Mr. Muhammad?
How are you?
You mentioned more than one shape being used as well shapes. So what is the shapes that being used in our Iraqi fields?
For Iraq fill, normally we are using J shape and also S shape and directional shape. Horizontal shape. For Ural Formation or Ramallah, especially in the south of Iraq, very close to Kuwait border, there is a big fault. So normally they are trying to drill a horizontal well to avoid this fault. And for a moderate depth, they are using a J shape. For a deeper well, they are normally using S shape because there is a lot of stations and a lot of organization and cities on the surface, so they want to choose just a best location and then start to drill in the direction of the well. But I think I remember before 1 year ago we drilled one well in south of Iraq with high step out. It's J-shape. The step out, it was around 1,300 meter, and the TD, it was around 3,740 meter. So they're using all type of the well, S shape and J shape. Also, they are using a horizontal, but horizontal, I mean, each 30 well, they just drill 1 to 2 horizontal well because it's very costly well, and also uh, the plan or the design for horizontal well, it's little bit complicated.
Muhammad, what is about the L shape? Do we use it in Iraq or we don't?
L shape, it's L shape, it's mean horizontal shape. It's horizontal well.
Okay. You mentioned that there is a salt and hard formation. So what do you prefer to start, salt or hard?
Normally the directional engineer or the directional driller, they would like to start with moderate formation or intermediate formation. I mean, intermediate formation, it's mean fluctuating between soft to moderate or moderate to hard. This type of formation is very friendly to build up, and also we should uh, check the tendency of the formation. I mean, because some of the formation, it's very tricky. I mean, it's intermediate formation, moderated to hard or soft to moderated, but also it's friendly to drop. It's not friendly to build up. So but I mean, in south of Iraq, they would like to start a directional job in moderated formation, and it should be intermediate formation. So for that, they are choosing the layout with intermediate section, like anhydrite dolomite section, and they start their directional job. Any more question? Okay. For lead angle, for lead angle, normally when we are drilling a well and when we are very close to the target, when we are very close to reservoir, normally reservoir is the soft formation because it's high porosity formation, and also the reservoir, it's it's like sandstone, or some of the reservoir is limestone, lime. So it's not soft formation, but we can say it's moderate formation with low compressive strength. Okay, so what's going on with azimuth? Because we have a phenomena, they call it walking to the right. The well, or the PHA, will train to create in azimuth in the direction of the right, because normally we are rotating to the right? When we are drilling, just rotating to the right. So normally it's walking to the right effect, or walking to the right phenomena. So we are creating an angle, we are creating an azimuth angle. So for that, the DD, or the directional engineer, they wanna to do a correction. Instead of the correction, they will create an azimuth, they call it lead angle, but it is turned to the left. It is turned to the left. Between the angles will be between 5 to 25 degree in the direction of the left. So instead they got any walking effect to the right, they will be in the sorry. So that's the main idea about the lead angle. Uh, Also, for your information, inshallah, we will working on this software is for it's like well-planned software, and also I will share the software on the Google class. If anyone, it's free on the website, so anyone wanted to download, it's very nice software. There is a lot of the items is calculate the hydraulic on pump flow train survey, conductor cementation, and also casing cementation, balance cement block, liner cementation, pre-record well data, vertical call sheet, and also horizontal call sheet, deviated well call sheet, cook tolerance, and also it's give you a very good idea about the tendency of the PHA. So it's very good software. I will try to upload it on the Google class today, and also I will upload some software, but it's well planned for Schlumberger company, but the issue it's with the software, there is no license for it. So if anyone can get a license, it will be perfect for him. I have just only the application, the software, and I will share it on the Google class. Yes, sir. The engineer asked me the lead inclination is turned to the left as a precautionary before the right by the tendency. Yeah, it's a precautionary grating in azimuth angles, turning to the left. It's like a precautionary action to just catch the plan in case we got any like walking effect or walking effect to the right. Okay, this my email. I will write it here. So please, anyone cannot can't get the Google class. Sorry, I put it on the private. I will share it on. Okay. This is my email. If anyone cannot get this application or this software, I will send it by email, and also I have some application for Schlumberger company. It's regarding well planning phase, but the problem with this software, there is no license. I have only demo license for myself, but it's just one license. But I have the software itself, so I will share it or upload it on the Google Class if anyone wanted to download it. And also I have two well plan. The first one they call it drilling utilities, and the second one they call it it's well plan software. I will share it on the Google Class. So inshallah, see you tomorrow the same time, 9 o'clock. And I'm very sorry for my language, English language, because my mother language is Arabic, and normally we are talking Arabic here. So maybe I will get some confusing during using English language. So inshallah, tomorrow we will continue the same session regarding the directional well and trajectory. So see you tomorrow at the same time, inshallah, 9 o'clock p.m. for a Middle East time, and also 6 o'clock for GMT time.
Mr. Muhammad, if you
Uh,
still have a few times, can I ask you just last question?
yes, of course. Go ahead.
Thank you, thanks a lot. Can you get back to the slides that contain the usage of direction well, multi-articular, and platform?
Yep. This one.
Yeah, of course, that one. What is the difference between the platform and multi-laterals, and how we can go to multi-directional from one point? How we can control the casing issues, the
No.
drilling?
This
I feel it's impossible.
this platform is offshore drilling. It's not onshore. It's not on land. It's offshore. And for a multilaterals
You
well,
offshore?
it's a it's onshore on the land. The difference is, and maybe the picture is look like is one conductor casing, but in the reality is not one conductor casing. It's a different casing. I mean, it's the different well, but the problem between casing to casing is just 5 meters. So in the picture or in the graph, it's look like it's just one casing, or it's showing is one path, but in reality, it's different well.
Yeah, I thought it's the same also. I've been
No.
confused by the
No,
picture.
it's like a cluster between well to well is just 5 meters, or between solar to another solar is just 5 to 6 meters. So it's showing like it's one well.
Yeah. Thank you. Thanks a lot.
No problem. Any question, please?
Can I ask some question?
Yes, please. Go ahead.
Can we drill?
Yes, Gibran. Do you hear me? Okay. I think there is an issue with the Gibran. Okay, inshallah, tomorrow at the same time. For your information, I'm start talking with one institute. It's online institute. So this course is free. It's completely free, and also if I can get authorized certificate, I will give it for everyone for free. But I'm not sure. I'm just start to deal with this online institute. So he promised me he will discuss and he will raise this point for a management, but till now I didn't get any answer from them. But he promised me like maybe he will give me like authorized certificate for this course. So if I get the authorized certificate, I will give it for everyone for free. So inshallah tomorrow at the same time we will get you here. So good night for today.